Welcome to a problem of the week example. On this one, I want to show you what I mean on the problems of the week. I'm taking one problem of the week in particular, this one, the who done it, and I want to show you what I mean by logical steps. You've got to solve these problems. What I'm looking for in these problems of the week is your growth in mathematical reasoning, logical reasoning. So on this one, so we got these four men, one of whom committed a crime, said the following. Bob said Charlie did it. Charlie said Eric did it. Dave said I didn't do it. And Eric said Charlie lied when he said I did it. Notice part A here. If only one of the statements is true, that's very important. And then part B will be the opposite. Only one is false. Who was guilty? Hint, try assuming Bob's statement is true and all the rest are false and see if everything is consistent. If that cannot be, then assume that Charlie's statement is true and all the rest are false, etc. Please carefully explain your reasoning on this one to receive credit. So what do I mean? Well, let's start. Let's do what they said. If only one statement is true, who is guilty? Try assuming Bob is true. So what if Bob is true? Here, I'll write right here. If Bob is true, what does he say? He says Charlie did it. That's what he says, Charlie did. So if Bob is telling the truth, that means Charlie, sorry, I'm not writing very well here, really did it, right? If Bob's telling the truth. Now notice it says only one statement is true in part A. In part B, we're going to do the opposite. And so in part A, only one is true. So if Bob is telling the truth, then the other three guys must be lying because they told us only one is true. So maybe Bob is telling the truth and the other three are false. Let's see, could that be? What does Charlie say? Eric did it. So that would mean if Charlie's false, he's not telling the truth. That means, and he said Eric did it. So Eric did not do it. That's what that would mean, right? That's logical, reasonable. Dave, who's also false, said I didn't do it. So if he's false, if he's telling a lie, and he says I didn't do it, that means Dave did do it. You tracking with me? Right? If Dave is telling a lie, if he's false, remember only one is true, and we said Bob is true, we're just guessing, you know. Bob is true and the rest are false. Then when Dave says, I didn't do it, if he is false, then that means Dave did do it. But wait a minute. Up here, if Bob is telling the truth, and he said Charlie did it, that means Charlie really did it. Wait a minute. They said one of whom committed a crime. I don't even need to go on with Eric. I can, with Eric here, just let me skip it. I'll just say, this is impossible because this means both Charlie, right? Charlie and Dave did the crime, right? Both Charlie and Dave did the crime. That's what that means. To have Bob be true and the rest be false would logically necessarily mean that Charlie did it and Dave did it. But they told us only one person committed the crime. You can't have Charlie and Dave. So this is impossible. What's impossible? It's impossible that Bob is the only one telling the truth. Okay, well, what comes next? If Bob, so we kind of like check off Bob. If Bob is not the only one telling the truth, then let's try again. Let me come on down here, and I'll set it up again for us. Okay, let's try again. So we did Bob already. Okay, so we showed that can't be. So let's check off. Oops, sorry, I'm being goofy here. There we go. We checked off Bob, he's done. It actually says Bod. I didn't know that. Notice that before. All right, next we're going to go with Charlie telling the truth. We tried Mr. Bod here being the truthful one, and he that didn't work. That was impossible. So next we're going to try, so this would mean false for Bob, and it would mean true for Charlie only, and false for Dave, and false for Eric, right? This is the next option we're trying. We're trying false, true, false, false, aren't we? Because again, only one is true, and it isn't Mr. Bod. We tried him and it didn't work. It was inconsistent when we tried to make only him true. It ended up having two people who did the crime. Okay, here we go. Let's try this one now. If Mr. Bod here is false, and he says Charlie did it, but he's false, he's lying, that means Charlie did not do it, right? He says Charlie did it, but he's false, so no way. What does Charlie say? Charlie says Eric did it, and he's telling the truth. He's telling the truth. So that means Eric, really did it. Okay. Whoop, I wrote the wrong thing there. Did it. There we go. All right, Dave. Dave says, what? I did not do it. But hold on, he's false. He's false. He's lying. I didn't do it, so Dave did it. Dave really did it. Wait a minute. There we go again. Look at that. We have two people. Impossible. Impossible. Two people did it. I messed up my writing there. Two people did it. So it cannot be the case that Charlie is the truthful one and everybody else is false, just like it cannot be the case that Bob is the truthful one and everybody else is false. All right? So far, if I write the four guys here, Bob, Charlie, Dave, and Eric. We've tried having Bob the truthful one and everybody else false. And that doesn't work. And then we tried having Charlie the truthful one and everybody else, right? Because only one is true, right? Only one is true here. Okay, and that didn't work. What comes next in the list? Well, it'd be that Dave's the truthful one, and then finally Eric's the truthful one, and everybody else false. We've got to try. So we got to try this scenario, and we got to try this scenario, and then you got to go through the statements logically, and what you'll find out is only one of those is actually possible, and the other is not. And once you know which one is the one that's possible, that makes all the statements consistent and ends up being only one person did the crime, then that's the way it's got to be, right? That's logical. That's not just me guessing and weird, strange feelings. We're about logic here. We're about what has to be the case based on truth. That's what math is all about. I'm wanting you to see that math is about logic in motion. That's all it is. It's reasonable. Math should be reasonable. It's not weird, strange tricks. It's reasonable. So that's part A. So you got to decide which one, then you got to decide who did it. That's all part A. And then for part B here, you got to do the whole thing again, but this time only one of the statements is false. So you've got to go through this whole thing again where you've got Bob, Charlie, let's try to squeeze it in down here, and Dave and Eric, and only one is false. So you got to start to say maybe Bob's the false one, and all the rest are true. And then examine their statements. Find out if that's possible. I think you will find this is impossible. There'll be some kind of like two people did it or something like that. And then you go, okay, next I got to make Charlie the false one and everybody else true. And find out if that's what. Then next I got to make Dave the false one and everybody else. Then I got to make Eric the false, right? You got to go through the four possibilities where it's Bob being the false one, then Charlie, then Dave, then Eric. And only one of those will be possible, consistent, and then that's the one that's got to be the case for part B. and then you'll know who's guilty. So that's how you would, and that's so this problem would take a lot of writing. You've got to write. I mean, not a ton, just like what I wrote here, but you got to do that 4 times for part A and 4 times for part B. Okay, so let me show you maybe 1 or 2 more of these, how that would work. So there's how that would work. For the diagonals one, you've, is that a good one to look at? Maybe. How about, let me see, how about, could look at open and shut case, mystery letters, whodunit, the mince, family man, mince, yeah, here, mince. Let me just show you this in real briefly. Basically, mince, I would make a guess and check table. So basically, it's 3 friends returning from a movie. After dinner, they paid the bill, bowl of mince. Sean took 1/3 of the mince but returned 4 because he felt bad. And blah, 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 blah. How many mints were originally in the bowl? So the bowl, so I would just guess. I would go, okay, the bowl started, I don't know, maybe 100 mints. I'm just going to totally take a guess. Sean took 1/3. Okay, so 1/3 of 100. Oh, if you take 1/3 of 100, it comes out to be a decimal, 33.3. He can't take 0.3 of a mint, so something's wrong already. So let me change my first guess to like 99, and then Sean can take 1/3. If you divide by 3, you'll get 33. So Sean took 33, so 99 minus 33, that's 66 left. And then it says, but returned 4. So afterwards, he took 1/3, he took 33, and then added 4 back. So plus 4, he left 70 when he was done. Does that make sense what happened there? I just took the 9, I'm just totally guessing. This is a complete guess, I have no idea. Divided by 3, 33 minutes left, and I'm sorry, 30. He took 33. So 99 minus 33 leaves 66, and then I added 4 because he returned 4. It says. So then that he left 70. Left 70. Next comes Feza, and Feza. What did Feza do? Took 1/4. Okay, so 70 times 1/4. Now, this is going to come out of decimal, so we know we're wrong again. But 17.5, he took that many. So we know we're already wrong. We know something's wrong with this guess. So well, how do you fix it? What do you do? Well, you might try to guess at a bigger, or not, maybe it's 98 or 97. We got to do odd, huh? Maybe it's 97. And then 97 divided by, well, that doesn't work. You got to go down by 3 because it's got to be divisible by 3. So 96 divided by 3. So go back to Sean again, and you just got to keep working it out and going through the various guesses until you get 17 left in the end. That's how you're going to need to work out that problem. So, right, so do you understand what I'm saying? So this would be, what, 32. He took, so Sean, if we started with 96, Sean took 32. 96 minus 32 is 64, but then return 4. So that leaves 68 left. And then the next guy took 1/4. Feza. He took 1/4, so 1/4 of 68, I think we can, is that right, 34, 17. He took 17. So 68 minus 17 leaves 51, and then he returned a couple, returned 4, so he left 55. And then you can go on to the last guy. Anyway, just keep guessing and working, see if you need to go higher or lower until you get it to work out, so there'll be 17 left in the end. There we go. So this is how you work out the problems of the week. They have to be logically explained all the way through, all of them. The diagonals, you can't, there's you can find a formula online. I think it's n times n plus 3 over 2. But just using that formula and plugging in 25 will give you the right answer. But that's not logic, right? You've got to explain to me logically why that formula is true, or I would probably do it with a pattern. I would say 4 sides, 2 diagonals, 5 sides, 5 diagonals, etc. You got to show a pattern. Find out how many 6 sides, how many diagonals. So I'm explaining to you in 7 sides, and then look for a pattern in the numbers. Or explain to me why this formula is true in a way that's simple and clear, enough logic to where somebody else in our class could understand.